In the penultimate module of this course, we'll be learning about how to load the Selenium page source information to BeautifulSoup in order to extract data from a dynamic web page. Here's what we'll cover in this module. First up, I'll give you a primer on BeautifulSoup and its components. Then, we'll see the how and the why of loading the page source information from Selenium to BeautifulSoup. And finally, for the demo, we'll use a combination of Python, Selenium, and BeautifulSoup to navigate to and extract information from a dynamic web page. Before we get into the practical implementation, let's get introduced to BeautifulSoup. What is BeautifulSoup? Straight from its documentation, BeautifulSoup is a Python library for pulling data out of HTML and XML files. BeautifulSoup helps you pull particular content from a web page, remove the HTML markup, and save the information. It is a tool for web scraping that helps you clean up and parse the documents you have pulled down from the web. Why use BeautifulSoup at all for this though? There are at least 3 good reasons for this. It is simple and Pythonic. BeautifulSoup provides a few simple methods and Pythonic idioms for navigating, searching, and modifying a parse tree, which is a toolkit for dissecting a document and extracting what you need. It doesn't take too much code to write an application. BeautifulSoup automatically converts incoming documents to Unicode and outgoing documents to UTF-8. You don't have to think about encodings unless the document doesn't specify an encoding and BeautifulSoup can't detect one. Then, you just have to specify the original encoding. BeautifulSoup sits on top of popular Python parsers like LXML and HTML5 lib. This allows us to try out different parsing strategies or trade speed for flexibility. Parsing HTML means going through the HTML code and extracting relevant information. Let's look at the type of parsers usually used with BeautifulSoup. There is Python's built-in HTML parser. Then there's LXML's HTML parser and also HTML5 lib. All of them have their pros and cons. If I could recommend one, then I'd recommend the LXML. It is very quick and works rather well. BeautifulSoup parses the given HTML document into a tree of Python objects. There are 4 main Python objects that you need to know about. Let's start with tag. The tag object refers to an actual XML or HTML tag in the document. You can access the name of a tag using tag.name. You can set a tag's name to something else. You can also access different attributes like the class and ID of a tag. The text within a tag is stored as a navigable string in BeautifulSoup. BeautifulSoup also allows you to access the comments in a web page. These comments are stored as a comment object, which is also basically a navigable string. The BeautifulSoup object is used to represent the document as a whole. Since it is not an actual object, it does not have any name or attributes. Let's look at the why and how we transition from Selenium to BeautifulSoup. Firstly, the why of it. Selenium itself is quite powerful in terms of locating elements, and it basically has everything you need for extracting data from HTML. The problem is, it is slow. Every single Selenium command goes through the JSON via HTTP protocol, and there is a substantial overhead. In order to improve the performance of the HTML parsing part, it is usually much faster to let BeautifulSoup parse the page source. The process flow for the transition is as follows. Navigate to the required website using Selenium. Then, perform the necessary browser actions such as filling in forms, search fields, clicking on links, etc. Once the desired data is on the page, get the page source information from the driver. And finally, pass it on to BeautifulSoup for passing the HTML data. So finally, we arrive at the demo that ties it all together. We use a combination of Python, Selenium, and BeautifulSoup to extract information from a dynamic web page. So what information are we going to extract today? We are going to extract some basic stats and news headlines for a footballer named Wayne Rooney. For those of you who don't know him, Wayne Rooney is an English football player who started his career with a club named Everton in the English Premier League. He then moved to one of the biggest clubs in world football, Manchester United. After staying with United for over a decade, he moved back to Everton and is now plying his trade in the United States Major League Soccer with DC United. Before we get into the coding, let's manually navigate to the data we're going to collect. Here's the website for the English Premier League. Here, we'll click on the Players tab. We'll then type in Wayne Rooney's name into the search box. There he is. Clicking on his name opens up the page that gives you an overview of his career and stats. If you scroll down, you can see the latest headlines about Rooney, both news and videos. That is useful information. We'll go up and click on Stats, which gives us a great view of his career stats in the Premier League. All these are what we're going to extract today. Looks like we've got a fair bit to do. Let's get cracking. In this section, we're going to code out what we discussed before. As usual, we start off by extracting all the relevant packages and adding the required options for the Chrome driver, nothing you haven't seen before. Next, we navigate to the Premier League's website. We then use the Find Element by Link text to click on the Players section. Now, there is a small waiting period before the search bar appears, which we take care of by using this explicit wait. We then find the search box element, type in Wayne Rooney, and hit return. There is another small waiting period. In the interest of showing all the sites, we use implicit wait at this juncture. The difference between implicit and explicit waits is that implicit waits tell the WebDriver to wait for a certain amount of time, no matter what, and explicit waits tells the WebDriver to wait until a certain condition is satisfied. We now click on the image of the player, which will take us to his profile page. Let's run this code block and see if everything happens like we expect it to. Yes, it does. The page source information is then assigned to the page source overview variable. It is now time for BeautifulSoup to enter the picture. We import BeautifulSoup and then load the page source information while parsing it with the LXML parser. Now, we need to locate the titles. If we go back to the site, inspect the news headline elements, we can see that it is located in the span tag under the class title. So, we use the findAll function in BeautifulSoup to find everything that is under the span tag and under the title class. And this is what it outputs. You can see we are nearly there, and all we need to do now is to get the text from these titles. That is exactly what this piece of code does. And as you can see, we get the latest headlines about Wayne Rooney. Next, we need to locate the stats button. On inspection, we can see it is under the href attribute. We find element by the xpath method and we click on it. And as you can see in the browser, we are now in the stats page. We get the page source information and load it into BeautifulSoup. If we inspect any of the elements we need to extract, we can see that they are all part of the AllStat container class. Let's try and get them all with the findAll function. And there you go. Here we can see that the stat titles are stored in the data stat attributes, and the stat numbers themselves are stored as text. To extract both of them out, we use the code shown here. We've come to the end of the demo for this module. But the thing to note is that whatever we've done from here can be extended to a much more higher level. All the players have such pages in this site from where you'll be able to extract their stats. You could then maybe put these stats along with the headlines into a pandas data frame and use sentiment analysis and other machine learning techniques to probably predict some of these stats for an upcoming match. There is very little Wayne Rooney specific code here, and whatever there is can be easily modified to make it player agnostic. That was just an idea off the top of my head. But the point is, web scraping like this can lead to so much more, and I encourage you to develop some ideas and try them out. The comment section on this course is open all the time to interact with me and amongst yourselves regarding these ideas and any other queries you may have. In this module, we got introduced to BeautifulSoup. We learned about the reasons for using BeautifulSoup, such as the fact that it is simple and can use multiple parsers based on desired trade-offs. We also went through the different objects and parsers in BeautifulSoup, such as the built-in Python HTML parser, the LXML parser, and the HTML5 library. And finally, we combined Python, Selenium, and BeautifulSoup to extract data from a dynamic web page.